Okay, now right now we are ready to find a basis. As I mentioned, guys, over here, we're going to talk about homogeneous linear. For homogeneous linear second order ODE, I should have two bases. I should have two bases. Now, in case one of them is given, how to find the second? I can I can know if there's some by guessing or by inspection or any other way, or sometimes it will be given how to find a second case. Now, the idea of this comes right away from the basis. Since I should have a basis, which means the quotient of the two is not a constant, means the quotient should be a function of x. And this method is called reduction of order. Now, I have two approaches. One approach that we will be using in this class, which is I have a formula, substitute all the information, and you'll be able to find your second solution right away. The second one is the long process, which is step by step, which is the first as the the first one, but it's going to take you longer time, and in both cases, we're going to call it a method of reduction of order. Now, you just start with the second order homogeneous linear ODE. This is the equation. I want you guys to note that this equation is written in standard form, means the leading coefficient over here is, and this is p of x, which is the coefficient of y prime, and this is q of x. Now, the method of reduction of order, if you apply it, you'll be able to find that y2 and y1, since both of them are solutions, means y2 cannot be proportional to y1, means y2 should be some function of x, some function of x times y1, cannot be proportional. And if we differentiate y2 twice, substitute in the ODE, try to simplify, and you'll get y2 equal y1 times integration of 1 over y1 all to the second exponential negative integration of p of x to x all dx. So basically, you need to find the p of x, which is the coefficient of y prime, plug it over here, find the integration, don't forget this negative, take the exponential for that term, and y1 squared, simplify all this expression, integrate it, and multiply by y. You will be able to find y. And of course, this term over here cannot be a constant, because if this one a constant, it cannot be a piece. So you should get a function of x. So you can just substitute the values and you will be able to get your answer. Again, the leading coefficient over here should be 1, and p of x over here is going to be the coefficient of y. Now, again, p of x is the coefficient of y prime after you write the equation in the standard. Okay. I have this problem. Find a basis. Basis means I need to find the two solutions for this homogeneous linear. ODE. I know I do have two, and one of them is how to find the second. Basically, guys, I need to use method of reduction of order. This method says I have to write this equation in the standard form. You cannot call p of x equal x. This is not right. If you do, you're gonna get a mistake. So what we do, we have to write this equation in the standard form. Standard form means I should have leading coefficient. So divide by x to the second. If you do this, your p of x will be 1 over x. Substitute in the formula, you'll be able to find the y2 equal x or negative 2 over x. Please, guys, try to do the calculations and do the integration, and maybe this is the formula. And if you have any problems, please let me know. Consider this one as a homework. Please do it and send me your answers. I will check your answers. Okay. This is another problem. This is another problem. I give you that y1 is a solution for this homogeneous. Here we go. Linear. Y prime, y prime y are linear. And I want you to give me the second solution. Now, as we did before, I should write this one in the standard form. So divide by x. This is the standard form. And if you use the formula, you'll be able to find y2 equals sine x over x. Again, I want you to do the calculations and let me know if you have any problem. Now, in this example, I'm going to do it in either way. I'm going to do it using the formula. I'm going to show you how to do it in the long technique. Now, this is the formula. This is y1. Now, I need to write this one in this equation in the standard form. So divide all terms by x to the second minus x. And then use the formula. If you use the formula, you'll be able to find that y2 is equal x ln of x plus 1. And should be easy integration. Should be easy integration. Now, if you need to find step-by-step solution, go to next step. And if you get this problem, we are not forcing you to do it step-by-step solution, but it's good at least to know one of the problems out there. Okay. This is step-by-step solution. We are assuming that y1 is a solution. So means that y1 prime can be found, y1 double prime also can be found. If you substitute those two in the condition in the ODE, it's gonna satisfy. Now, to find the second solution, I'm gonna call it y2. Now, keep in mind that y2 cannot be proportional to y1, means y2 over y1 equal function of x, and this is u function of x. So our problem is to find the function u of it. So basically, u is a function of x, y1 is given, that is y1, and this is y2. And since we're assuming y2 is a solution, means that y2 is satisfying the equation. So I'm going to find y2 prime, y2 double prime, and here we go. You have this term, you have this term, you have this term. Substitute those in the equation, and this will give you this expression. Right now, I'm going to collect the terms. I'm going to collect the terms, and you're going to find out that sometimes going to be cancelled out. Going to be cancelled out. If you do some simplifications, your equation going to be simplified to x to the second minus x u w prime plus x minus 2 or u prime equals 0. And if you look at this one, this is very special equation. And in this equation, guys, basically I can make a substitution. I'm gonna call, for example, u prime. I'm gonna make substitution at here. I'm gonna call it v, for example. If this is v, this should be v prime. And this where my second order being reduced to first order. So this is why we call it reduction of order, because we are reducing our equation from second order ODE to be first order ODE. And if you make the substitution that I just mentioned, here we go, and this is going to be your equation. And this is the first order ODE. Can be done easily using the techniques that we learned in chapter 1. Could be separable, could be linear, could be Bernoulli, could be exact or non-exact. And luckily, this equation is separable. If you solve for v and you move this one term over here, click towards you click all x together, all this together, you're gonna find out that you with the integration that your v equal this expression. Now, what's v? V is equal to prime. So you have to substitute the prime and do the integration again, you'll be able to find y is equal to u times x, which is the same as what we did before. You see, guys, this is a little bit long, but this is step by step, and the idea we call this one reduction of order because of this step over. Oops, this is step over here. Over here. This is what we call reduction of order because I'm reducing second order ODE to be a first order using this substitution. And this is what we call reduction of order. So if you want, you can do it step by step, or you can do it using the unheritage. Okay, unheritage. So those are the two solutions. Why you want? Now, I'm gonna stop over here. Then I'm gonna do the second part of the section, which is missing X and missing Y in a separate view. Thank you guys, and I will post the second video shortly.